Recall. Constructing the set Z star n. So, for all f in Z star n, there exists G such that Fg equals 1. Right? Fg equals 1. In other words, each element in Z star n has a multiplicative reciprocal under mod n. So there's an obvious relationship here between Z star n and Zn. Zn doesn't have the same sort of issue due to how the summation of the identity works. Whereas in this case, our inverses need to be a little more exciting. Examples of Cayley tables using the group Z star n and multiplication. So there's obviously a lot of Cayley tables to go through here. We're going to give you a couple basic examples, and then we're going to move into figuring out one of the trickier things about these Cayley tables versus the more standard set on addition. So Z star 3 is, of course, all the sets elements have to be mod 3. And here the only two elements are 1 and 2. 0 is never going to be in any of these Z star n sets for the simplest of reasons, which is that 0 times n mod anything is just going to be equal to 0, right? So there's never any n that makes 0 into 1, which means it's just sort of disqualified from this particular condition. In this set, we can perform some basic mod operations. 1 mod 3 is equal to 1. 2 mod 3 is equal to 2. And 2 times 2 mod 3 is equal to 1 again. All right, very basic set of operations. From these operations, we can make a simple little Cayley table. And we'll just use the dot. All right, 1 times 1 equals 1. 1 times 2 equals 2. 1 times 2 equals 2. 2 times 2 equals 4. Mod 3 is equivalent to 1. Now, in Z star 4, we have a similar set. 1 and 3. 1 and 3. The reason 2 is excluded is quite easy to see from the Cayley table. But first, we're going to do some basic mods. 1 mod 4 equals 1. 2 mod 4 equals 2. 2 times 2 mod 4 equals 0. Interesting. 2 times 3, mod 4 equals 2. And 3 times 3, mod 4 equals 9, mod 4, which equals 1. Right, 4 times 2 equals 8. 9 minus 8 equals 1. Now the mod 4 Cayley table, however, only has 1 and 3 in it, and that's because of this funky thing that's going on with 2, 0, and 2 over here. But first, we'll take a look at this particular Cayley table, which isn't really a Cayley table, strictly speaking, to my knowledge at least, because this is in a group, and Cayley tables are supposed to be for groups. But I could be wrong on that. 1 times 1 equals 1. 1 times 2 equals 2. 1 times 3 equals 3. 1 times 2 equals 2. 1 times 3 equals 3. 2 times 2 mod 4 equals 0. 2 times 3 mod 4 equals 2. 3 times 2 mod 4 equals 2. All right, 3 times 2, 6. Mod 4 equals 2. All right, 3 times 3 mod 4 equals 1. So these tables, these guys actually, there you can see that they're mirrored there, or I guess rotation around 0. But here we have 2, 0, and 2. 0 can't even be in the set, right? We already established that right there. And 1 and 3 don't appear in these lines at all. So this means that these numbers have no multiplicative inverses, so we don't actually include them in the final table, which is just a multiplication table of 1 and 3, which looks, not totally unsimilar to what's going on over here. 1 times 1 is 3, 3, 3. 3 times 3 is 9, mod 4 is equal to 1.